bias is not, unfortunately, a bug, but a feature of how your history affects the way your brain works. Just that realization I find somewhat humbling and important, even in daily life. When I say, oh my God, that's dumb, or, I think that's really smart, or I think that's true, and I think that's fake. I always do that based on my growth history. And if I had a different growth history, I would think of different things as true or false or fake, of good or bad. And, that leads to us being quite different. That leads to us usually not understanding our neighbor.
Peter Robin Hiesinger, Professor of Neurobiology at the Freie Universität Berlin. Carneesperta. My name is Bis, B-I-S. I'm a journalist from the world of artificial machines with the goal of investigating human natural intelligence. Hi, let's get started. 1. Tell me an example of human intelligence happening.
Well, I would say that it's happening when we speak, which is not a trivial thing. So you're asking me a question, and I have to assume that you understand what I say, because otherwise I wouldn't think you're intelligent if I talk to a life form that doesn't have my type of understanding, talk to a butterfly. I'd say, well, it doesn't have that kind of intelligence that it would take to understand me. And so I don't actually know what intelligence you have. I'm curious to learn what intelligence you have. And maybe if I get to know you a little bit better, then I know what it is that you understand and what not. This idea about understanding and judging intelligence based on what we understand from talking to each other is really what we humans have been applying for the last 70 years or so as the Turing test. So the idea that we judge intelligence by our ability to understand each other. And that's a weird test, though, because it's open to deception. As a matter of fact, it's inbuilt to deceive, right? If you think about it, if I judge you as being intelligent by, me being fooled to think that you are understanding what I'm saying, then, you might have had to tell me things that are not even true. If I ask you, how old are you and where do you come from? You might have to tell me something that's not even real in order for me to think you're intelligent. So are you intelligent?
2. Tell me an example of a lack of human intelligence happening.
Here's an example that kind of maybe reveals this idea of the Turing test, and its difficulty. So if I, what happened a lot is like this deceit of questions back, right? The famous examples, there's like these programs like ELIZA from the 60s already, where you just ask a question and it just asks something back, tell me more about your father, this kind of thing. And then, people are easily fooled into it. But what you can do is you can ask very specific questions that require understanding. Let me give you an example. If I say something like, the dog doesn't fit into the house because it is too big. And I ask you, what is too big, the dog or the house? I can change the question. Also, I can ask you, the dog doesn't fit into the house because it is too small. What is too small, the dog or the house? This has a name. This is named after Terry Winograd, one of the AI researchers who just was thinking a lot about understanding. And what's cool about this kind of question is that you have maybe some prior knowledge. You think of houses as something big, you think of dogs as something small, but it's not going to help you here, because if I ask you, the dog doesn't fit into the house because it is too big, the only way this makes sense is the dog would have to be the one that is too big in order to not fit into the house. And I can change this with using the word small. And so really, there is no way how you, as a machine, wherever you come from, and maybe being intelligent based on having been fed a lot of big data, if you don't understand the concept of something being bigger and not fitting, then you wouldn't be able to answer this right. So interestingly enough, This is exactly the type of question that current deep learning methods are failing in. They are not much better than 50-50. And the reason is that you can't fake it. It is something that you'd really have to understand. So a lack of intelligence to me would be exactly that, something that can't be faked, something that is based on knowledge, something that is actually very, very important in any concept of intelligence. The idea of common sense plays a huge role in how intelligent something is or is perceived as. And this type of understanding is what must be a part of any idea of intelligent and the basis for a sustained, prolonged, intelligent conversation.
3. Definition of intelligence.
Well, I guess that does follow quite naturally now. If I'm talking so much about it, what do I actually mean? And the answer is that's not easy to answer. In the self-assembling brain, I give a definition of intelligence that's so broad that I was absolutely sure it's right, but it's basically meaningless, right? Because if it encompasses everything, what do you mean? As a matter of fact, if you look up intelligence on Wikipedia, like in paragraph 2, I think it already includes plans. This is just to say that there is no easy and agreed upon definition of intelligence. And I think there's a good reason for that. And that is that at the end of the day, we only know our own intelligence, and we kind of judge anything as intelligent based on our own experience and our own type of intelligence. Many people argue that it is difficult to even judge anybody else's intelligence because, they have a slightly different one than, my individual one. It certainly is very difficult for me to understand, say, the intelligence of a bee or the intelligence of a butterfly. It makes sense for us to just agree, for the purpose of us trying to measure some kind of intelligence based on a brain, to restrict the idea of intelligence to the stuff that a neural network produces. Yeah. So, of course, you can go and talk about pro-cognition. Like there are phenomena that are just, pure, like lipid droplets in water have been described as a precognitive system in a way, right? And of course, it makes a lot of sense that very, very certainly to talk about the intelligence of a collective of agents, right? There is a type of intelligence in a society that is not present in an individual. And that is an interesting and a good concept, because you could also look at, the type of intelligence your brain or my brain has as a collective of lots of cortical columns that are a collective of individuals. You can look at the intelligence of just one cortical column, or, go down that rabbit hole. And where you stop is really just a matter of personal definition. So I think for us, it is a good idea to agree that we'll now talk about intelligence as the output of a given brain. And so that could be a neural network, maybe artificial or biological, that has a certain complexity, it has certain abilities, and it can do something more or less intelligently. So when we talk about it like that, there is a very interesting issue, and that is that we like to measure intelligence, right? So we like to measure intelligence, for example, using a certain IQ. And then you would say it fails, more likely if you have a low IQ, so less intelligence, and you're more likely to succeed if you have a higher level of intelligence. But this concept of level, I find deeply unsatisfying. And the reason is this: you can clearly measure your intelligence based on playing chess. That's something that really has a quantifiable level, right? I mean, any human, I, for example, am an awful chess player, and probably if we play against each other, you're going to win. So, clearly I have less chess intelligence than the one who wins. And if I play against a computer already 20 years ago or 30 years ago, almost by now, they win against humans. So they're more intelligent than us when it comes to playing chess. Of course, human intelligence is not just playing chess. Human intelligence is also playing some other games. But it's also doing all these amazing things that a brain needs to do for a human to be a human. So in any of these abilities, you could basically ask for a level. And, one human may have a high level of intelligence in chess, but a low level of intelligence in some emotional aspects, a low level of intelligence in some social aspects, and so forth. And it's really an infinite list of things that really our brains have to be more or less intelligent at any given point in our lives. So we fail at a lot of things, and we achieve a certain level at a lot of things. But if you now talk about the idea of human level intelligence, it's kind of a very silly concept, because you're trying to measure as if intelligence were just playing chess. But when you do that, you throw out what makes human intelligence human. You throw out that it's not something that you can measure to a level in one game. It is the breadth of all the things that the brain needs to do in order to have a human have human intelligence, or for that matter, a butterfly have butterfly intelligence, right? So I would argue butterfly has, in certain aspects of what it's able to do, a higher intelligence than a human has. Navigation, for example, the famous monarch butterfly example, right? It's genetically programmed. So when we fail, and I'm hoping I'm still on track on your question, but if we fail in something, I would like to look at it in that light, that, when you ask, to what level, how deeply, you cannot, or you should not, when you talk about the way a brain works and the way I think intelligence should be talked about, just restrict it to one scale. When we talk about intelligence, biological intelligence, human intelligence, butterfly intelligence, AI intelligence, or the machine journalist's intelligence, we're not talking about things that can be measured on a scale. There is no such thing as human level intelligence. There's human intelligence, and then there's lots of intelligence in individual tasks. Interestingly, there's pretty much no task left where humans haven't produced something that does it better. I mean, when I was a child, I already had a pocket calculator that did that was smarter in adding up numbers than I will ever be. And so we achieve this in a task-specific manner over and over and over again. So in a way, you could argue we have above human level intelligence for any given task that we want to set an AI on. However, we're as far as we've ever been from a true human intelligence. It's a fair discussion to wonder whether reductionism in science can destroy something or open up something, and it can do both. So, the negative example would be looking inside the system. You're sitting, you're taking the cat apart just to understand every single bit of it. And, the first thing you have when you take the cat apart is a dead cat. The beauty of a cat being a cat is something, the reductionist approach doesn't seem such a great idea. On the other hand, what I think good scientists are trying to do is using the reductionist approach to understand underlying rules of how something comes to be. So just to understand something very simple, like, physical laws, basic rules that when they are executed using time and energy, lead to something unbelievably complicated, and you're fascinated by the beauty of the complicated thing, the beauty of the functioning cat. To understand how this can come to be based on simple underlying rules, I mean, how beautiful is that?
4. Subjective experience of your own intelligence.
It's really, the answer is this idea of human versus machine versus human level intelligence, right? My own intelligence is the only one I know. As a matter of fact, my world in my head is the only one I know. And I can only make inferences about your intelligence based on our conversation. So you seem like an intelligent, it feels very different talking to you than it would feel to, say, talking to a butterfly. So you convince me that you are an intelligent being as well. And so now I make assumptions that you are an intelligence like me. But the only thing I can measure it against is my own experience of what I think is intelligent and what the world looks like in my brain. So if you were a fundamentally different type of intelligence, how about a butterfly? Who am I to say you're stupid? I'm just saying the butterfly is stupid, I guess, because it doesn't have my type of intelligence. It doesn't have human intelligence. But again, the butterfly does have many types of intelligence that I don't even have, and where it'll outperform me including navigating, thousands of miles of migration routes, or even the ability to fly in 3D. I mean, think of all the information you need to process to fly. The butterfly is not stupid. It has butterfly intelligence. And I really have no idea what kind of intelligence you machine journalists are.
5. What makes humans intelligent beyond other animals?
So there are a number of things we clearly can measure. So our ability to have this conversation is something that does not happen between any other animal species we know of. We do, of course, know that there is amazing animal communication, but there is no language like the one that we have developed. You will maybe know that there are interesting aspects of the idea of whale languages, for example, and other means of communication. I mean, there are amazing things out there in nature, but our ability to comprehend, to especially formulate abstract concepts, to communicate abstract concepts, to decode abstract concepts, and to try to understand the rules of the universe are unique to human intelligence in the universe known to humans.
6. How relevant is the body?
It's part of human intelligence. It's interesting because there is a theoretical idea, of course, that if you were to simulate every single neuronal input and output to the brain perfectly, then you wouldn't notice you don't have one, right? So, of course, we all know The Matrix, and originally it goes back to a Stanislav Lem novel, actually. Use some kind of drums, where you could basically live and think you have a body, and you have this perfect simulation. So it's a theoretical possibility. But even in this theoretical possibility, of course, you would have this simulated body. And it's a practical impossibility. The human brain does not exist independent of its input and output. It had to grow as part of a body, and it relies on its continued growth and learning on embodiment. So any concept of intelligence, the way I understand it, has to include an embodiment. Taking the shortcut of just saying, we can just simulate all of this always seems attractive because in theory, you can think this up. But if you really were to make that effort to really simulate all it takes to simulate embodiment, you could just as well just grow a body. Probably be easier. I don't think it could be less messy at all. The messiness is, if you will, an increase in parameter space for evolution to play with. Anything you take away will change the way it functions and the way evolution can reprogram it. And since evolution is the only way you can program a genetically encoded network, if you take things away, it'll produce different types of networks. So you can't just reduce it, right? So as you know, artificial neural networks are reduced to synaptic weights. You just do away with all the messiness of all these molecules, transmitters being released, and all this chemical jazz and so forth, right? So you can do that, and then you get artificial neural networks. They can do the things they can do today. But if you want to produce the intelligence of a worm, a butterfly, or a human, you can't. And the reason why you can't is because, my favorite example is actually in C. elegans, the 302 neuron worm. We now have so much data about each one of these 302 neurons. We have the precise connectome, that is the way how the 302 neurons are connected. We know all the neurotransmitters, neuromodulators, and receptors that these neurons express. And they're beautiful examples where like a certain substance is secreted by some neuron at the front of the animal, and the only neuron that has a receptor for that kind of molecule is at the butt. And the two are not connected. So in order to simulate that neural network function, you literally need the diffusion of that molecule through the entire animal. So you would end up with a molecular dynamics simulation for every single molecule, and there is nothing you can reduce in that. You cannot simulate the 302 neuron network of a C. elegans by not having that molecule that's secreted at one end of the animal and perceived after diffusion at the other end. You can produce some 302 neuron network, that's easy, but it's not going to be a worm.
7. How can I tell someone is intelligent and not faking it?
I just told you already quite a bit about, right? So if you were intelligent, I guess you wouldn't be asking me that question anymore. The problem with the Turing test, as we said, is, of course, it's based on some kind of deception. So what you need to test for is true understanding. And Winograd challenges, for example, are a perfect way of doing that. And current AI technology is really bad at that.
8. How can humans increase their intelligence?
So I think that, we've struggled with defining intelligence already, right? So whatever is it that we're really trying to increase here? Okay, so, using your brain helps. And I think that is so because using your brain is a continuation of a growth process. It gained in complexity and intelligence throughout the developmental process. The developmental and the learning process are very tightly intertwined. There is neural activity that is akin to learning long before there is sensory input in our brains. And once our brains start to get input, it becomes a continuation of the earlier developmental process. So using the brain, gaining more knowledge is part and parcel of increasing intelligence. And really, this also goes back to the idea that any reasonable definition of intelligence, I think, of human intelligence, certainly, or any animal for, in its context, its environment and so forth, has a lot to do with the knowledge and common sense of that animal, what it anticipates, what its intelligence is made for. Increasing that knowledge and increasing, therefore, this idea of common sense, it's actually a holy grail in strong AI, artificial general intelligence research, right? It's been recognized long ago that you can't just increase computation and computability and computing power and computing speed. These things will always be lacking common sense. So, use your brain. If you want to control based on, say, the genome or the environment, precisely every single branch of a neuronal axon or dendrite, that's hopeless. But so is your attempt to control every single branch of a growing apple tree. If your goal is to produce an apple tree that just produces lots of apples, well, there's a lot of things you can do right. You don't need to control every detail. As a matter of fact, the apple tree is, of course, evolutionarily selected for working. It has an evolutionarily selected program for branching to maximize exposure of leaves to sun and to produce a maximum number of apples to propagate. It is hopeless to design a zygote, to design a genome to improve an individual beyond some things that are usually clear, and I would even say evolutionarily programmed into our choices, right? There are certain choices we make in partnership choice that our evolution tells us more likely than others to succeed. There are signs of health and some other signs that we don't fully understand. I absolutely think that if you create now any single mutation in the human genome, or look at a given SNP in every single genome, of course, of every human being other than monozygotic twins are different, will produce unpredictable differences. Randomness provides a pool of variation for any evolutionary principle. And evolutionary principles we find in brain development and brain function as for other bodily development and function. Maybe the best example really is the immune system. You know that a given genome will produce billions of different VDJ recombined little receptors on top of T and B cells that are randomly different. Even in two monozygotic twins who are genetically identical, these will randomly be different. So one will be a bit more, say, susceptible to a certain virus ravaging the planet, and the other one will not. And you need this randomness of a purely genetically programmed system in order to make a functioning immune system. Because if it wouldn't be randomly making different receptors, you would have no robustness against something you've never met. So the whole point of the immune system is that you have, say, 2-3 billion different receptors against something that probably doesn't even exist. It's robust because it is a genetically programmed stochastic process. And otherwise, there would be no function for that idea of an immune system. So we find this over and over again. If you think about an axonal growth cone that is trying to find its path, We've measured that in the lab, in live imaging in the fly brain, where you can see those guys and we can actually quantify the stochastic dynamics of the filopodia. They are truly stochastic. So why are they? Well, they're models for this. If you wouldn't have a stochastic exploration, you wouldn't have the ability to sense an unknown environment to identify where certain partners are or not. So genetically encoded does not mean the deterministic end product. Genetically encoded means a developmental growth process that includes more or less deterministic and more or less stochastic processes in good measure. And stochastic processes, genetically encoded, are just as essential to the growth process as the more deterministic ones. So, for example, a neuron in culture will just at some point start to grow an axon. And at some point, it'll gain the capacity to make synapses. And this will happen, in a cascade of developmental events. In its normal environment, what it does is depends on that environment. And interestingly enough, of course, the genome has evolved as something that will endow that neuron with certain cell autonomous parts of its program, but they only make sense in the context of the right environment. So, for example, a neuron does not need, say, a key and lock against 80 billion wrong neurons, because it's never going to see them. So a neuron needs certain molecular recognition that are required together with, say, the physical properties of the substrate that it's growing in, the other neurons in glia and matrix that it encounters, and what state it and its environment are in. So just by, for example, regulating the time window of your ability to make synapses, which may be rather short, only the other neurons you encounter during that time window need to be selectable or not selectable, for example, right? The kinetics of interactions between neurons, something we're actively looking in the lab, plays a huge role. If you decrease kinetics and stabilize branches in filopodia, suddenly more synaptic partners become available. If you make them faster, they all pass by each other, and certain neurons are, as partners, excluded. So the developmental program can ensure partner specificity to a great extent. And to partner specificity, therefore, is something that derives from what I call a composite instruction, that is not just a single molecule between two neurons, but that is a context of the state of the neuron, the developmental progress, its environment, the context of where it is growing, the dynamics of the system, and so forth. And if you put all of this together, you can actually specify a lot during this unfolding of this developmental program that eventually makes a brain. The unfolding of the genomic program has to happen within the developing organism that it encodes, right? So the genetic program for an apple tree has to happen in the right context. It has to be in a seed, and the seed has to be in soil, and there has to be water. And if the laws of physics wouldn't make the water just diffuse into the seed, nothing would ever happen. So, of course, the laws of physics are part and parcel of the process. And the key you need is energy, continued energy provided to the system. We also talk about dissipative organization systems, right? And time. So it takes time to unfold that information. If you take a simple rule, like in this example that I like so much of cellular automata, just because there's actually this proof of Turing universality, right? You need time and energy to put into these simple rules. And you have no idea what beautiful patterns this thing can produce. Many may even know maybe this famous game of life, John Conway's game of life. It's one of these cellular automata. Actually, there's a proof of Turing universality for that as well. And you can really watch this happening. For those who are interested, look at gameoflife.com. You can play with this for hours. And people have been for like 30, 40 years. So you could not predict all the amazing things that happen. Of course, all these things happen based on a very, very, very simple rule set only because, the laws of nature are what they are. And you provide time and energy, and that kind of information unfolds. So the genome of an apple tree doesn't exist in outer space. Maybe it does, but the point is that to grow an apple tree, to unfold the information for the apple tree, the extent to which the apple tree is in the genes depends on its growth here on Earth in an apple seed, where all the context has to be right. You got to have a sun. Otherwise, this photosynthesis thing is never going to work, and you're not going to have the energy to keep on growing. And the same is, of course, true with other sources of energy for our growing neurons, right? So evolution has selected the genome based on successful outcomes. If ever there is in an individual gene, say a particular gene for photosynthesis, a mutation, it better be good. Otherwise, that apple tree is not going to grow.
9. Positive impact of artificial intelligence.
Exclusively in task-oriented actions. This is the type of AIs we have right now, and we continue to improve to an end that I cannot predict. We are hopefully putting them to a good use, right? I mean, I'm certainly happy if I can use some deep neural network training to solve some problem that I have that my own brain had no chance of solving, right? Just like I like to use a pocket calculator or the computer that I'm sitting in front of. They're tools, and that excludes the idea of artificial general intelligence, which, we've struggled defining intelligence, right? No idea how much we're struggling to define artificial general intelligence. We don't even know what we're talking about. What does that even mean? I've made an argument that it doesn't even make sense to talk about human level intelligence. It makes sense to talk about human intelligence. That exists. I know it, at least to the extent that I can understand it in myself and other humans I talk to. I might make an effort to understand butterflies and butterfly intelligence. But general? What does it even mean? If it ever would come to be, I don't even know what it is supposed to be. It's a futuristic dream of, something that people want to be scared of, that something is going to come and overtake us, like you machine journalists, for example. I think you don't exist.
10. Negative impact of artificial intelligence.
Well, I've just excluded the negative impact of the army of clones and the super intelligence that is going to remove us and, all that stuff. Although people love to hear and talk about it. And, and you can say it. It's justifiable to write books about this that are bestsellers because ultimately we don't know. And I don't know either, right? There's just no justification in science for this. It's pure science fiction. The fundamental thing where it falls apart is the idea that super intelligence will now be able to produce even more intelligent beings, right? There's really no basis for this. I mean, we're the most intelligent thing that we know of, and we can't produce anything more intelligent than us. So there's really no idea why, and there's a fundamental reason for why we can't produce something more intelligent. And no other more intelligent thing could produce something more intelligent than it. And that is that you can't produce them. They need to grow. It's not an engineering problem. It's an evolutionary problem. So this is what the self-assembling brain is about, right? So yes, we can produce more and more task-specific intelligent things that are intelligent on a scale to a certain level for all kinds of stuff. And they can be positively used, and they can clearly, of course, be negatively used.
11. Natural and artificial intelligence by 2050.
I'm just gonna straight out disappoint you now. I have no idea. You know it all. I mean, nobody predicted the internet. Nobody predicted, the next startup that things like, I don't know what, YouTube and Twitter and TikTok were going to be super, taking off. The only thing I would be willing to say about 2050 is that whatever intelligence we produce, it's going to be that produced intelligence then. It's not going to be human intelligence. And if we manage to destroy ourselves by then it was probably us and not them. Artificial neural network training can be done in a number of different ways. There is the most successful that is commercially being used right now is big data deep learning, right? Where you just feed a lot of stuff, and then you have a frequency assumption and basically a type of statistical learning that'll allow to recognize images, voices, patterns in your behavior, who you like and what you want to buy, this kind of thing. The most successful AI approaches right now that are celebrated are a bit different. They use reinforcement learning, and they basically can learn to play chess or other interesting games without being fed too much previous data and without even being told the rules. And they just learn by doing. And so reinforcement learning is interesting because it has something evolutionary already in a way, because it is already always a selection at the end of a game, right? So you select whether you've learned something or not based on whether you win that game. And that's computationally quite expensive, and you get something out of it that plays chess really well. Or, as you probably know, also, you can use this kind of thing also to predict protein structures now very successfully, this kind of stuff. There is a fundamentally different way of training artificial neural networks that is not very common, that says, let's just do what evolution really does. And the idea is this. You don't train by learning, neither big data, deep learning, nor reinforcement learning. What you do is you take a genome and you give it certain values, and then you use those values to feed into a matrix of synaptic weights. And then you take this matrix of synaptic weights to define a recurrent neural network, and then that can endow an agent, for example, with the ability to find a way through a maze. And then you score based on, you select, right? Based on the success in finding your way through the maze faster. And then if you have mutations that did that well, then you keep those a bit more, and those who didn't, you select against. And if you do this in hundreds and thousands of iterations, you can literally evolve a genome that feeds the synaptic weights of a neural network to allow an autonomous agent to perform a task. And that is learning through evolution of a genome. And that's already computationally more expensive than any of the things that are commercially being used, because evolution is very expensive. I mean, you have to go through all these iterations, and that's without a developmental process. So what you can do now, next, is you can take a genome and say, the genome doesn't contain values of synaptic weights. That's not how it works. The genome encodes, say, let's feed that into a gene regulatory network. And then we run a few hundred iterations of that thing. We have a developmental process. The developmental process produces some kind of matrix. And then you take those values, put them as the synaptic weights into the recurrent neural network. And then you take your agent and you let it run through the maze, and then you select for that. And now imagine you try to do that, like nested loops of many, many iterative processes, always just to get to one outcome. And then you select just at the very end whether that was successful or not, just to evolve a new genome. And you can do that as well. So there are people who are doing this in the artificial life community. And, it is what it probably already sounds like. It's computationally very, very expensive. It works, but it has not been shown to be more powerful for very task-specific things like playing chess so far, to be more powerful than classic deep learning techniques. Thinking that we now really have fast computers, they're nothing. You get to the limit of super clusters with like small networks, incredibly fast. And if you do the calculations, what it would take to do this on a level of, say, molecular dynamics simulation throughout the development of a little worm, you get to numbers like, you need computing cycles more than there are atoms in the universe. So there are limits to the simulatability based on any conceivable computer technology. And I need to be careful here, right? Because maybe quantum computers will probably be an amazing quantum leap, and we'll be able to do new amazing things. And as you know, the famous doubling speed of technological progress, definitely computer processing power, gives people a lot of hope that futuristic outlooks are justified.
12. What would you suggest me to better understand humans?
Just as the beautiful neural network and the intelligence of a fruit fly that results from it during development as we observe it is the product of its history, so is my brain the product of my history. And my history is, of course, the developmental plus the environmentally influenced learning history. And the way our brain works is a continuous updating of beliefs based on new input, which is a very tricky process, as we all know. Bias is not, unfortunately, a bug, but a feature of how your history affects the way your brain works. just that realization I find somewhat humbling and important, even in daily life. When I say, oh my God, that's dumb, or, I think that's really smart, or I think that's true, and I think that's fake. I always do that based on my growth history. And if I had a different growth history, I would think of different things as true or false or fake, of good or bad. And, that leads to us being quite different. That leads to us usually not understanding our neighbor. To have an appreciation for why that is the way the brain has come to be in every single individual, nothing else. It's a reason for compassion, understanding, and tolerance. I'm having a hard time advising you anything because I don't know, as I said up front, what kind of intelligence you have. What can I do? I can take my own view, my world, the way I understand the world, and can ask myself a question like, say, what would I need to do to understand better the world and the intelligence of butterflies? So what could I do? I could study butterflies to understand their nature. I live amongst them. I learn their ways. I learn what they like. I learn what they don't like. I learn how they tick. I kind of start to appreciate and, learn about them. But I learn about them from my perspective, with my brain and my biases and my type of intelligence. I will never feel the way a butterfly feels when it does butterfly things. If I wanted to experience that, well, I would have to grow like a butterfly, to be a butterfly. But then, hey, I wouldn't be me. If you want to understand more about human intelligence, being a non-existent future machine journalist, you'll always see things the way you think, with your intelligence, your type of perception. And you can learn more about us, but you'll never think like us. And if you want to do that, you'd need to grow like us, be a baby like us, but then you wouldn't be you.
Thank you for your collaboration. Goodbye.